Board. All right, here we go. For the first of, I don't know, even know how many times we're going to take notes. Today is 8/24.
Yep.
What we are going to do for the first probably few days, maybe the first week, is we're going to review something that we learned in Algebra 1, and it is factoring quadratics. When you took Algebra 1, we factored quadratics and we stopped. That was it. Okay. In Algebra 2, we're going to spend our first probably 5 weeks doing nothing but factoring. And it's going to go from quadratics to cubes to lookalikes to grouping to blended, um, multi-step sort of blended. It's quite a beast of a unit, but I've been doing this for a while that I start the first unit with, let's just take a couple days and refresh that we do know what factoring means and that we do know how to factor um, just basic expressions, right? All right. So a quadratic is anything that has x squared as its highest exponent. So there might be a couple other stipulations to be made, but if you see like x plus 4, that's not a quadratic. But if you see something like x squared plus 4x minus 32, that is what we call a quadratic expression. What would turn it into a quadratic equation?
You add.
If I had an equals or equals 0 or equals 3 or something like that. Correct. So anything that doesn't have an equal sign in math, we just call it an expression. So all we're going to do here for the first few weeks is just break things down. And the act of factoring is something that you've been doing since like grade school. In little kid school, like fourth grade, when you factored, you just took something and broke it down into things that multiply to make it. There's no way that you took an elementary course in this country and that no one ever asked you to make like a factor tree, right? So they would give you like the number 32, whoever your teacher was, and they would give you little branches, right? And whoever he or she was, your teacher, they would have you go around the room and say, give me some numbers that make 32. And one person might say 4 times 8, just might say 2 times 16, who knows? But the act of doing that, the act of breaking something down into two things that multiply to make it is what we call factoring. So let's keep that like forefront of our minds that is all we're doing here is we're taking something and breaking it down into multiplicative pieces. So when you factor a quadratic, does anyone by chance, it's been a hot minute since we've done this, does anyone by chance remember how to factor this quadratic trinomial?
It's the parentheses,
Hmm.
and then you do the x. You have to, isn't it? You have to figure out what factors from 32 that adds up to the fourth.
Yep. Basically, at the end of the day, good way to get us started on this one, Wyatt. It's for most of you, it's been quite a while since anyone's asked you to do this. So that was a really good jump start for us. So what we're doing is we're building a couple of what we call binomials that if we were to multiply them back out would equal x squared plus 4x minus 32. So as a little bit of a reminder for you, let's just do a quick practice problem. If I gave you like x plus 5 times x minus 8, and I asked you to multiply that out, you would follow a four-step process. It's pretty straightforward. You would take x times x, right? And get x squared. And then you would take x times negative 8 and get negative 8x. And then you would take 5 times x and get plus 5x. And then you would take 5 times negative 8 and get minus or negative 40, right? The acronym that math teachers sometimes use for this is FOIL. If you ask your parents about FOIL, they might vaguely remember it from high school, honestly. It stands for first terms, outer terms, inner, and last. So, yeah, you don't need to say FOIL. It's just kind of an acronym that people use. Anyhow, at the end of the day, when you combine, by the way, which two terms could be combined in my problem over here? Which colors? Just the purple and green, right? The red is an x squared, so he says I don't have anybody to go with, and the minus 40 says I'm just a constant. I don't have anybody to go with. But the two purple and green ones are like, hey, we're both linear terms. We're both regular xy guys, so put us together, and we get minus 3x. So what we're going to spend the day doing is just that backwards, right? So like Wyatt said, we're going to see if we can take what's given and break it back down into the pieces in the parentheses. So good start. So Wyatt knows we build the shells first. We're going to be building a lot of shells. And then we ask ourselves questions in a very particular order. It's very important that you go in the right order. Question number one is this. Because the number in the back is negative, will my two shells have plus plus, minus minus, or one of each? One of each for the win. 100% of the time, because to make a negative 32 at the back, there's no way in God's green earth I could do that with like two pluses or two minuses, right? So step one is I hop in and I say, well, I don't know exactly what the numbers are yet, but I sure know that there's going to be one plus and one minus. And then this is where knowing your times tables obviously pays dividends. What numbers specifically are we thinking of that multiply in this case to make 32?
Start off with four.
Yeah, I think 99% of people, if you ask them, provided that they know anything about math, would say 4 times 8. And so let me try just putting them in 4 and 8 like this. And John's shaking his head, and I agree with you. Like this is not correct, right? But it's important that we are able to identify why it's not correct. It's not correct because of that yellow connector, right? Like I'm not a dummy. I know x and x make x squared. And it's not correct because of the 4 and the negative 8. Those make negative 32. It's not correct because what does that purple problem make?
Positive.
Positive 4x. And what does that green problem make?
Negative.
And if you add 4x and negative 8x, you get negative 4x. And so we can see that we didn't do a terrible job, but it doesn't work because we wanted the purple and green to make plus. That's all we ever do, right? Whenever you get the right number with the wrong sign, just leave everyone where they are and just take your sign. So instead of it going a plus and then a minus, let's switch it to a minus and a plus. And now we're right as rain because if you add the purple and the green, you're back up. The power struggle is won by the plus this time and not the minus. So uh, that's we're not going to go that slow all the time. I just wanted to, it's only fair because it's been a while that remember, is just a simple act of factoring a quadratic trinomial. All right. So now that we've survived our first one, let's do another one. And that's it. I mean, you're done. You factored. Woohoo. Let's go this one. Step one. Parentheses. But you're going to hear me say it, and you don't have to use my terminology, but I call it build the shells. I think it's important that we build the shells. So many questions can be answered by just starting. And the starting here is lay down some foundation. Give yourself a little bit of a workspace, right? And now I'm ready to hear conversations about math. What goes first? The X's. Like that's first dad joke of the year. That was an excellent answer. First of 512. Yeah, our first goal is to make x squared, right? And that's not going to happen unless I put an x and an x here, because now I know that x times x will make x squared. The next fundamental question is to talk about what the signs are going to be. What are they going to be? They have to both be positives. And here's what's interesting about factoring is if I just pointed to the yellow thing, this is really important that you follow the vibe here for the next 30 seconds. If all I pointed to was the thing with the yellow arrow, you couldn't tell me what the signs are. You could tell me that they can't, though, be one of each, right? Because then they'd multiply to make a negative. But the thing about it is if all you look at is the 27, then you don't really know enough. But it's a teamwork thing now. When the number in the back is a plus, it's a teamwork thing. And then you have to say, oh, I need a little more information. And that's where the 12 comes in and says, I got you. They're both pluses. The guy in the back tells me they're both the same. The guy in the middle tells me in more detail. Right. So we're going to put a plus and a plus. And again, you're going to find the answer in this case is the first thing you think of. What are the numbers we're looking for?
7.
Nope, nope, nope. They have to multiply to make 27. You're fine. That's why we warm up. I can see getting rid of calculators is going to be a good thing for us. Yeah, they only harm us. It's funny as a teacher when you sit and you make your note card and you think about where am I going to get stuck? I do it all the time. Where are my students going to struggle? I did not see you guys coming up with 3 times 9 as the place that we were going to get stuck today. But you know what? The world is full of surprises. This job is always keeping me on my toes. And of course, 3 times 9 makes 27, unless I'm having a stroke, and 3 plus 9 is 12. And then we're done, right? Okay. That was all right. Let's try again. Let's do y squared minus 10y plus 9. Step 1, build your shells. Step 2, what are the signs? They both have to be negatives. And again, it's a team effort. There's no one number that tells me that, right? I look at the 9 on the back and he doesn't say the answer. He just says, by the way, they're both going to be the same because they got to multiply to make me and I'm a positive. And then the guy in the middle bails us out and says, I got you. They're both minuses. So you can chuck your minuses in. And let's see if we can do a little better this time. What numbers are we thinking of that multiply to make 9? 9 and 1. That went better that time. Thanks, guys. Yeah, so 9 and a 1. And again, you instinctively might think of 3 times 3, but you realize quickly, the thing about factoring is you just try something and when it doesn't work, you go, oh, well, and you try something else. So 9 times 1 makes 9. And then when you add your purple and your green together, and even if I don't draw them, when I say purple green, I'm talking about this and this, right? All right, you guys good on those? All right, let's talk about a couple flavors of problems I wanted to get across to you today. So that's just what we just talked about was just a real simple, basic warm-up quadratic trinomial. Got it? Now here's another one. It is still a quadratic trinomial, but the difficulty level will go quite a bit higher now. And why? What is in this problem that wasn't in the last 3 or 4? The 3. Good call. Yeah, that 3 in the front is a much bigger deal than people give him credit for. At this point, if you were to look at our last examples, like in this problem, we were looking for numbers that multiplied to make 9 and added to make -10. Numbers that multiplied to make 27 added to make 12. Numbers that multiplied to make -32 and added to make 4. That does not work now because of the 3. We are not looking for numbers that multiply to make -12 and add to make 5 because they don't exist. And even if they did, it's not what we're looking for. The dynamic has shifted because now when you build your shells, what's different?
You have a 3.
You got a 3, and you can't just go in here willy-nilly and do something stupid like this, right? You don't need a guy like me to tell you that that's not smart, right? Because x times x ain't going to work. It's not going to make 3x squared. So what we think about here is, okay, so you're going to change the whole dynamic of this problem, Mr. 3, because I need you in the front. And now you're going to affect multiple things. Some things just don't change though. Like what are the signs? Yeah, one of each, which is nice. I don't have to look at the middle term with a one of each, or I just know if the back is -12, I can just put a plus and a minus in there. Do be advised, like we saw in that first example, that you might have to change them. You might have to change them to minus and then plus. That's what erasers are for. It's no big deal. And then we just start kind of diving in and getting our hands dirty here. I need some numbers that multiply to make 12. Take a shot.
6 and 2.
I'll take it. And what we're about to learn is that these red numbers, they might work. They might not. And if they don't, we're not going to like carry on and say, oh, I suck at this. We're just going to try something else. And again, we're not testing the yellows. Of course, 3x and x make 3x squared. And of course, 6 and -2 make -12. That's not what we're after here. The factoring is all about the purple and the green. What do the purples make? 6x and the greens make negatives. That clearly those make 0x. We weren't trying to make 0. We were trying to make 5. It's no big deal. It's totally normal. Try, fail, try, ding, you get it, maybe, who knows. So what else could I try? Take it? Switch them. Yeah, don't forget you can switch them. And like changing the 2 and the 6 changes the dynamic of the whole thing, right? What did the greens or the purples make?
You got positive 2 or x.
2 in the greens? -18. And if you do 2 in the middle and -18 on the outside, 2 and -18 make -16, and we are 0 for 2, and that is totally fine. The moral of the story is, though, we just figured out that 2 and 6 are not our guys, right? So logically, where else do we go? 4 and 3. And this is just normal factoring. You might remember that with factoring, it's not, you're not being punished by the math gods. It's just, it is what it is. You try until you hit it. Purples, middles,
Yeah. Four and
4.
nine.
So the purples make a positive 4x, and the greens on the outside make a negative 9x. And what do those make if you add them together? Did we want negative 5? So we move the signs. Again, the infrastructure is good. The 3x and the 4 and the x and the 3 are right where we want them to be. We just got to do the sign switch now to change the dynamic, change the power. And so we give the minus and the plus instead of the plus and the minus, and now the balance comes out to +5 like we wanted. Okay. And then finally, there are these. And then we do have to talk about difference of two squares today. I got about 6 minutes. I wish I had about 10, but I'll just make do with what I've got here. So, does anyone by chance with a really good memory? You're going to hear me say this word a lot this year. Does anyone know why this problem just sucks?
Five.
Yes, you have a very non-prime number in the front, and that's a thing. It's a poopy thing. And that last problem, I had no problem with us just committing to the 3x and the 1x. It's the only way to make 3x squared. But now I would have a major issue if you just throw it down and say, I got you, Mr. Ahern. There's my shells.
No.
You're like, what are you, high? Like, did you forget? Did you forget? And then someone goes, boom, all right. And I go, what? Are you still smoking the devil's lettuce here? Because you're forgetting that there's other possibilities. So be advised as you're factoring that there's the really easy ones, there's the kind of mid levels like that last one, and then there's problems like this that just are out to get you. And this is where we really want to kind of generally break off into teams is how I would do it. Like if you three were working together and you had this on a homework assignment, you might say, hey, Jess, you're going to try the 12 and 1. Peyton, you're going to try the 6 and the 2. You know what I mean? Like everyone's going to kind of have their different job. But as a class, I would tell you my personal strategy is I usually start with the one where the numbers are closest together. So I get more success if I start with the ones that are tighter, the 4 and the 3. What do we know our signs are? One of each for sure. So we can put in a plus and a minus and just know again that we might have to switch it to a minus and a plus. No big deal. And what do you think of in the back when you think of 12? I'm not, I like 4 and 3 again. I'm just saying. So, and just because time's ticking, I'm gonna cut us in a little quick here. But if we put a 3 here and a 4 here, why is that smart?
Then you also, it's not just gonna multiply the four, well, it will move. It will.
The more your summer rust wears off this week, the more you're going to start to see why I did that. And the more you're going to realize that, wait a second, what's 3 times 3?
It's just
9. And what is 4 times -4? And what's 9 minus 16? -7x, right? So that's good news is that we just have to switch the signs, right? So we're going to switch it to 4x minus 3 and 3x plus 4. All right, in my final 3 minutes, I want to show you just one more flavor of quadratic, and it's this little guy here. Do you remember this little fella?
Oh.
It's really, I go back and forth on how to teach this. It's really not all that significantly different than what we've been doing. As a teacher, I don't like to do this. I'll do this once, and then I'll probably never do this again. I'm within my rights to say that, correct? And at this point, you realize, oh, this isn't any different. I'm just looking to build shells, right? And I'm looking for, what are my signs going to be? They're not both going to be negatives. There's going to be one of each for sure because they multiply to make a -36. There's no way around that. So there's going to be one plus and one minus. But the magic of this is what am I trying to make in the middle? 0. And so I'm not thinking of 4 and 9 or 3 and 12. I'm thinking of numbers that will cancel each other out, specifically 6 and 6. So as a general rule, when you see a problem like this, it has a name. It's called a difference of two squares. And when you go to factor a difference of two squares, there's really not a lot of trial and error involved. You just want to be smart about it and say, oh, you're trying to get me to kill off that middle term. Well, the only way to do that is to have symmetry. And it's beautiful because the purples make the 6 and the greens make the -6, and poof, there's your gone. And that works for more fancy ones as well. So like if I had this, it's a difference of two squares. And all you do is build your shells. What is the square root of what I just circled in red? 3x. So you put that here and here. What is the square root of what I just circled in purple?
7.
So you put that here and here. And all you got to do now is just don't be a knucklehead. If you want the middle to go away, you just got to make sure you give one positivity and one negativity. And whatever they are, they'll vanquish each other down to zeroness, right? So that's going to conclude today. I kind of had to cut a little bit out, but that's fine. Would you like me just to wait and give you your first assignment tomorrow? Are you good with that? I'll just hold on to them, and when class starts tomorrow, maybe a quick warm up, and then I'll hand out assignment 1 to you. Deal? All right, just like that, day 1, we're off and running, man. It's like we never left. So, yeah.